My name is Anna Manning. I am obviously a fourth year forest engineering student, and my final year project was looking at the uptake and barriers of geospatial technology in New Zealand's forest management sector. So geospatial technologies have emerged as a powerful tool for optimizing forest management and enhancing decision-making processes. They can provide more accurate and detailed forest management. Gaining knowledge on the uptake and barriers of geospatial technologies will help inform the industry on how to fully capitalize on their acquired data, as well as develop strategies to overcome any barriers identified, ultimately providing widespread use in the industry. 2 studies have been conducted on the uptake and barriers of geospatial technologies in this sector previously, a benchmark study in 2013 and a follow-up study in 2018, highlighting a need for a more recent analysis. This study addresses 3 main research questions: identifying current geospatial technologies employed in New Zealand's forest management sector, identifying barriers hindering the adoption of geospatial technologies, and determining the progress and uptake of geospatial technologies over the past 5 years. A literature review was undertaken, which aided in creating a draft survey. The survey was also based on previous studies to ensure comparable data was collected. However, an update was updated to reflect the current state of geospatial technologies. This study was dependent on industry involvement to ensure accurate data. So a key step of this project involved identifying who the best contact was at each company. The survey was then distributed to respondents online, with data analysis commencing after this. This is a summary of the respondent details from the survey. The survey was sent to 29 companies, with 27 completing the survey, a response rate of 93%. Of these companies, 23 were forest owners or managers, and 4 companies were forest consultants or research institutes. The combined area managed by these companies was 1.2 million hectares, representing 74% of New Zealand's plantation forest estate. These forest estates range from 7,000 hectares to 200,000 hectares. The majority of respondents were in GIS-related positions, with 22 GIS roles, 4 foresters, and 1 wood flow manager. The first section of the survey looked at the use of geospatial positioning technology. GNSS receivers used by every company were split into 4 categories: receivers built into devices, such as smartphones, consumer-grade handheld receivers, mapping-grade receivers, and survey-grade receivers. There has been a shift in the type of receivers used, with consumer-grade devices such as smartphones becoming increasingly popular. Survey-grade receivers are also on the rise due to their importance in co-registering ground-based reference data with remote sensing data such as LiDAR. Handheld receivers decreased slightly from 2018 to 2023, which could be a result of companies moving towards built-in receivers due to their increasing availability, accuracy, and low cost. The primary applications of GNSS receivers included boundary mapping, field navigation, and operational monitoring. Aerial photography remains a critical tool for the industry, with every company indicating its use. Aerial photography applications included cutover mapping, stand and forest mapping, wind throw assessment, and harvest planning. Wind throw assessment has had a significant increase in application between 2018 and 2023, with only 2 companies previously indicating the use of aerial photography for this purpose, compared to 26 companies in 2023. Additionally, 48% of companies derive photogrammic point clouds, an increase from 32% in 2018. This could be due to the lower cost associated with photogrammetric point clouds compared to LiDAR point clouds, despite creating similar accuracies. The most used products from photogrammetric point clouds were digital elevation models and stem counts. Multispectral imagery increased from 48% in 2018 to 67% in 2013. The most common barrier preventing companies from using multispectral imagery was no perceived benefit. This differs from the lack of staff knowledge and education being the largest barrier 5 years ago. This could be an increase in skilled GIS workers entering the workforce, potentially influenced by undergraduate and postgraduate courses being taught at 12 tertiary institutes around New Zealand currently, with over 50% of young geospatial professionals having postgraduate degrees. Companies derive various products from multispectral imagery, including true colour composites, false colour composites, and vegetation indices. The main vegetation index used by companies was the Normalized Difference Vegetation Index. Additionally, the main applications multispectral imagery was used for were cutover, stand, and forest mapping, harvest planning, wind throw, and forest health assessments. Cutover mapping showed a significant increase since 2018, with only 3 companies using multispectral imagery for this purpose. Hyperspectral imagery was used by 9% of companies in 2018 and decreased to 4% in 2023. The low uptake of hyperspectral imagery was expected due to the extensive data processing used with dealing with a high number of bands, as well as the acquisition costs. The most common barrier was that companies saw no benefit to acquiring hyperspectral imagery. Applications currently used by companies for hyperspectral imagery were limited to forest health assessments and species identification. The use of photogrammetric processing has proven to be a viable alternative for species identification, therefore limiting potential benefits of hyperspectral imagery to companies. The uptake of LiDAR has had the most significant increase in the past 10 years, with 93% of companies now using this remote sensing data. All companies managing 10,000 hectares or more acquired LiDAR data. One of the biggest changes in LiDAR data acquisition between 2018 and 2023 was the introduction of open data portals. This was one of the most common ways companies acquired LiDAR data. The National Elevation Program, which aims to provide LiDAR data coverage across 80% of the country, has contributed to the availability of freely accessible LiDAR in New Zealand. Whilst this data is limited in some parts of New Zealand, it covers a significant portion of New Zealand's plantation forestry. The introduction of accessible data has created opportunities for smaller companies that were restricted by cost of acquiring LiDAR. Furthermore, the availability of ready-to-use products derived from LiDAR, such as DEM and digital surface models, have benefited forest managers who previously did not have the expertise or resources to process LiDAR data themselves. Both the 2013 and 2018 survey suggested that cost was the largest barrier to acquiring LiDAR data. In 2023, the survey indicates that the cost is as much of a barrier as staff knowledge and lack of training and lack of perceived benefits. As more LiDAR data becomes openly available, it can be expected to see an increase in usage. The most common applications of LiDAR data were forest mapping, forest inventory, hydrological feature identification, and historical and cultural site identification. All of these applications have seen a significant increase in usage by companies since 2018. Artificial intelligence was used by 30% of forestry companies when working with geospatial data. The barriers to not using artificial intelligence included staff's current lack of knowledge and training, no perceived benefit, and not being aware of artificial intelligence models, and cost. Artificial intelligence models are typically used in conjunction with remote sensing data, with aerial photography being the primary source, followed by multispectral imagery and LiDAR. The most common applications for AI were stand and forest mapping, forest inventory, and tree detection. The increasing use of artificial intelligence in today's society is reflected by the growing use of a notable portion of forestry companies. However, the common barriers preventing companies from using AI models were the lack of staff knowledge and education. More education and training for geospatial professionals will be required to understand the processes AI models utilize. Tertiary education and training providers will likely have the most impact on the future uptake of AI models. AI models were used in conjunction with high-resolution aerial photography, highlighting the importance aerial photography will always have in the forestry industry. The results of this survey show an uptake in and continuing use of geospatial technology in the forest management sector. An overall change in barriers preventing uptake suggests that to get the most out of geospatial technologies, the industry should focus on increasing exposure to available technology, as well as providing training on the latest technology, such as AI. The results from this study will inform the industry on how to fully capitalise on their required data, as well as provide educational institutes up-to-date teaching models.